Hi everyone. So today I'm going to go over provide a deep dive video for C++ vector. So basically, this is the mind map I created for what we have learned so far in terms of a vector, and so I will walk through all the core concepts of the vectors based off this mind map. So let's get started. And so first, what exactly is a vector? So I think at its core, think like vector is more like a a dynamic array. So we know the basic arrays we all learned first, like the int my here array bracket 5. The problem of those is that their size is fixed. So if we declare an array of size 10, we cannot easily add like a 11th element. So this is where the vectors comes in. A vector is like a dynamic array. So that means it can grow or shrink automatically when we add or remove elements. So it handles like all the messy memories management for us. So um, the elements can stored continuously in memory, just like the regular array, which means that accessing any element is incredibly fast. So we kind of get the best for both sides. So the flexibility of a list with a speed of an array. So that's why vectors is such a cornerstone for C++. And so that's that. And next, let's get started with the essentials. So to start using array vectors, we need to include the right header files. The first step here, it's very straightforward. Just add include vector at the top of our source file. It's not negotiable. Without it, the compiler won't know what a vector is. And the second part is to use um, the correct namespace. So we have a couple choices actually. First, we can either type like here every time, which is very explicit and good practice, especially when the project large. And we can also for smaller and quick programs, we can also just use like namespace std here to save some typing. And but be aware that this can sometimes lead to name clashes if we have our own functions or classes with the same name as the standard ones. So we need to be mindful to choose the method that best fit our project's needs. And so next, it's now that we already set up. So how do we actually create a vector? So there are also few common ways. So first, we can create like an empty vector, like here, std vector, insert numbers, and this gives us a clean slate ready to fill with data with our programs runs. And second, we can create like a vector with a fixed initial size. For example, here, so we can say the vector double temperature 5, create a vector with 5 elements, each initialized to 0. We can also specify um, some different initial values like vectors kind of names um, and finally, actually kind of my personal favorite is that for small known collections, it's the initialized list. So it's available since C++11. So which lets you write there's something like std vector like in prime, something like this, and it's concise, easy to understand, and it's clear to show the initial contents of our vector. So and next is the some key functions. So let's talk about the most common things we would do with a vector. So adding elements and checking how many they are. First, to add an element to the end of the vector, we use like a push back here. Um, a method, it's like a symbol, it's intuitive. We call it like vector pass the value when we want to add, and behind the scene, the vector just basically manages its memory. If it's running out of the space, it will automatically resize itself. Isn't that cool? So to find out how many elements are currently stored in the vector, we use the size parentheses methods. It returns the value of the type size, which is an unsigned integer. So this is important because when we write loops and iterate through vectors, we always use size t for our index variable to avoid compliance warnings and like potential like bugs maybe. Yeah. And now let's look at two functions that help us to manage the vector's memory most directly. The first one, it's the resize n, change the size of the vector. So if we make it larger, it adds the new elements, and if we make it smaller, we could chop off the elements that from the end. The second one is the reserve end. So it's about capacity. So capacity is like the total number of elements that the vector can hold without needing reallocated memory. So reserve. So the second one, reserve, like ensures the capacity it's at least n, so it doesn't change the size. It's just like prepare the vector for future growth, basically. So yeah. And next, it's basically arguably the most important concept to understand vectors, the difference between size and capacity. And so let's break it down with an analogy. So imagine a vector is a bookshelf, and the size is the number of the books that are currently on the shelf. The capacity, on the other hand, is the total number of books that the shelf could hold. So if we have 3 books on the shelf and the shelf can hold 5, the size is 3 and not 5, and the capacity is 5. So now when what happens when we add like 6 books? So the shelf is full, so we need a bigger shelf. So this is called a reload allocation. So we buy like a new bigger shelf, I don't know, from IKEA, I don't know, Amazon, to move all our existing like currently books to the new shelf, and then add the new and the 6 books. So this moving process is what can be slow if it happens many times. So we use a reserve likely to buy like a sufficiently larger bookshelves up front, basically, yeah. And next step, it's some unique features of vectors. And so let's say we have like 2 vectors, vector 1 and vector 2. If I do vector 2 equals to vector 1, sometimes it's powerful, something powerful could happen. So vector 2 becomes a complete independent copy of the first vector. It is not just pointing to the same data, it gets its own brand new copy of all the elements. So this is called the deep copy. As we can see in the example, after copying, so if I change the elements to vector 2, the vector 1 remains completely untouched, and this and it's very safe and intuitive, so we don't have to worry about accidentally modify the original data when we just want a copy. So we have our own vector to fill with data, but how do we get individual elements out there? So we have 2 main options actually. So the square bracket operator method and the add parentheses methods. So the first method is similar to array like syntax. It's very fast because it doesn't do any checking, but this speed comes at a cost. It's unsafe because if we try to access an index that doesn't exist, the result is undefined behavior at like parentheses. It's safer, and so the parentheses is a safer alternative. it does the same thing, but first it checks if the index is valid, and if it's not, it will throw an exception. That means our program won't silently failed. So which one should we use though? So as a rule of thumb, I would say I use the first one, the bracket operator, when we are 100% sure that the index is correct, and then use the second method when the index is variable or during development or we're just unsure, right? So that's pretty much lead us to the end of this presentation. So let's get to some like most common like mistakes that programmers would make with vectors. And first, it's the most common and most like dangerous one. It's the out of bound access. So because we need to always double check like our loop conditions and consider using add parentheses for adding safety. So second is to use try to use like the square bracket to add elements. So this is like a very common mistake as well, because bracket operators for accessing existing elements, not creating new ones. So we must use like the pushback here, parentheses, and third, more like non-common but still kind of major pitfall is that the type of the return value of size is the size t and it's unsigned integer. So if we write a loop like for int I equal to 0, I smaller than vector size, so we might get like a compiler warning. So the fix is simple, just declare our loop variable as size t here pretty much. And yeah, and so let's provide like a quick recap of what we covered so far. That was very dense. So a vector, it's basically a dynamic array that automatically grows and shrinks. And to use it, we need to use includes like a vector header first, and use like the std namespace. And we have covered like how to create the vectors in variable in a couple ways, and essential functions like pushback, size, resize, and reserved. And remember the crucial difference between size, which is the elements of the number of the elements, and the capacity, the total allocated space. And the vector creates like a deep copies of on assignments, which is a great safety feature. And when assessing elements, choose between the fast square bracket operator or the save at add parentheses. So, and finally, watch out for those common pitfalls like such as assessing out of bounds, typing to the add element with the square bracket, and mismatch like variable size with the size parentheses. And if you remember this, if we remember this like key points, I think we are pretty in good shape to using vectors efficiently in C++. Thank you.